Hello. Can you hear, students? Are you able to listen to me? Right. Sorry, there was a little delay because there was an internet issue at my end. So we lost about 3 4 minutes. Anyway, let's begin from where we stopped yesterday. Like yesterday, as I was at the display function, I was at the display function, and in the display, let's understand that we are taking a temporary pointer. That temporary pointer we are calling it as current, short form of current. That current is equal to first. So the current is standing here. Assume that it is at the left extreme, that is minus 9999. So also there is another temporary pointer called as express current, and that is also standing at the express first. That is this one. That I'll show you a little later. So let us see the first while loop. The first while loop, the curve was standing. Curve is replaced. I mean the base address of the first is also in curve. So curve is having address base address not equal to null, true. So it's going to display the curve of key, that is minus 9999, and curve of value which we have taken as minus 9999. Then curve is equal to curve of next. It comes over here, displays the value, curve of next 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 displays the value, and curve of next displays the value, and then curve of next. It becomes null. So null not equal to null, false, right? When null not equal to null is false, then it comes to the second while loop. And in the second while loop, it is going to show the the express lane nodes, right? Express nodes. So as you have seen it over here, express curve is initialized to first. So it's starting over here. Then it is not equal to null, true. So it displays the value 9999. Then it advances to the next pointer, that is the next key, and displays the key and the corresponding value. Then it advances to 30, displays the key and the corresponding value. Then it advances to the rightmost extreme, that is 9999, and displays the value. Then it advances to null. So null not equal to null is false. So it's going to come out of this while loop. It's going to come out of this while loop. Now today we are going to see the search, right? Because in the syllabus you have insertion, you have search, and you have deletion. So search, let's make an assumption that this is our status. This is our status, and we are going to look for the particular key. We are going to look for a particular key. So we'll see the cases. We'll see the cases and try to understand the code. But while I am explaining you the code, I'll suggest that you open your dev C++ compiler and start typing it also, so that at the end of today's session you have the complete search logic with you. Now I'm initializing the global variable flag with 0. I'm initializing the global variable flag with 0 because the search function will again be called while inserting a new node, right? While inserting a new node, we require the search function. So keeping that in mind, I have declared a global variable called as flag, right? This flag, as you are calling this function search, it is basically initializing to 0. Let's at this point neglect the count. Count we are not using, so I have commented it. So you also need not have to type it. Now the temp1, which is a pointer of struct node type, temp1, which is a pointer of struct node type, we are bringing it to first. We are bringing it to first. So temp1 is standing, say, over here. First is also standing over here. Now let's take the case 1. In the case 1, let's assume that the user has given the value of k as 22, right? User has given the value of k as 22. Means what? The user is wanting to search whether the key 22 is existing or not. Whether the key existing to 22 is existing or not. Okay. So the value of k, we are taking it as case 1. Say, assume it as, say, 22. Right? Flag is initialized to 0. And as I told you, first and temp1 both are standing over here. Right? Now, temp1 not equal to null. Right? Temp1 has got some base address which is not null. So we enter the while loop. Having entered the while loop, it is going to check whether k is equal to temp1 of key. Where is temp1? And what is the temp1 of key? 10. What is the value of k which we have passed? 22. So 22 equal to 10, false. So it's not going to enter the if block. It's not going to enter the if block. What's going to happen then? It's going to come to the second if block. In the second if block, the condition is what? K greater than temp1. What the value of k? 22. 22 is greater than equal to temp1 of key. Where is the temp1 standing? Here. What is the temp1 of key? 10. Right? So this condition is getting satisfied. That is 22 is greater than 10, true. Greater than equal to 10, true. So it's going to print the temp and the flag. Right? It's going to print temp and the flag. And then increment the flag to flag plus plus. So flag is going to become 1. Are you understanding this? We started with flag as 0. We entered the while loop. This if condition is false. This if condition is true. It's going to print and increment the flag by 1. So at the end of this if condition, the flag is 1 and temp1 of key is 10. Because if condition is satisfied, you are not going to enter the else block. You will go to temp1 is equal to temp1 of next. Temp1 was here. Temp1 of next comes over here. Right? Temp1 of next will come over here. So temp1 of next temp1 not equal to null, because it is at the base address of 20, which is not null. So we are going to take a re-entry in the while loop second time. Again, at this moment, at this moment, the value of the key is 20. Yes. What the value of k? 22. 22 equal to 20. False. So it's again not going to enter this if condition. So it checks in the second if condition. What the value of k? 22. What the value of temp1? Temp1 is 20. True. So 22 is greater than 20. This 22 is greater than 20. So it's going to enter the second if condition. It's going to print the value and increment the flag by 1. That's how the flag becomes 2. Right? The flag becomes 2. It's not going to enter the if block. It's going to come to temp1 is equal to temp1 of next. So it comes over here. Temp1 not equal to null is true. Right? Now what the value of temp1 of key? 22. Are you getting my point? So 22, what the value of k? 22. 22 equal to 22. True. When it is true, we say found, and we are going to display the key and the flag. And set one more variable called as key found, which is a global variable, to -1 and return. Return means what? Is going to come out of the search function. It's come out of the search function. Are you clear about the case 1? If anybody has got any doubt regarding the case 1, please come in the chat window. Yeah, anybody who has not understood case 1, please come to the chat window. While such we should come from express lane. No, sir. Yes. See, this search is also is for the node, right? This search is for the node, but I agree with Nikhil Reddy that the searching should come from the express node. So search express node also is a function, which is going to be on more or less similar lines. But what we are doing, we are searching the node. Okay, Nikhil, we are searching the node, not the express node. But I am agreeing with you. While searching, we have to come from the express node because the whole idea of skip list is to add an express node so that the search is faster. But the present code which you are seeing is for searching the nodes. Nikhil Reddy, this particular code is only for searching the node, not through the express node, but we have to actually come through the express node for faster search. But the code which I am presenting to you is only for searching a node, because when we are going to develop the search in the express node through the express node, if a key is not found in the express node, for example, Nikhil Reddy, I'm talking to you. For example, the user has given key as what? 22, right? Is the key 22 there in the express node? No, right? So the logic in the when we come via the express node is that first we go to 10, right? K value, that is 22, is greater than 10, true. This is going to advance 30. Then there should be a logic. For example, then it should come to the else block. Then it will come to the else block, and in the else block, we have to define something and go back one step. That is, come back to the 10 and come down and go to 22. Nikhil Reddy, once again, I'll explain it to you. Suppose the user has given 22. We have started with the express node 10. 10 is greater than 22, so it is going to go to the next node. Next node is 13. Key 22 is less than 30. So we are supposed to come back to the normal lane and search in the normal lane for 22. That is our ultimate aim, right? So from 10, when you come down, when you start advancing, you are searching in the normal lane. That searching in the normal lane is this code. Nikhil Reddy and others. Right. What is the other question? We go down. We always search node with help of express node. Yes. Okay, sir. Yeah. So, are you understanding the case one? All of you? Sir, I have a doubt. Void in it. Okay, Raghavendra Reddy, Raghavendra, we'll come to that in it once we finish this. Just remind me once we finish such. There's one more case which I want to discuss. We'll discuss definitely. But you please type and keep your doubt ready so that when I come to you, you display the text. Let us first resolve the search logic, search node. Right. So if there is no doubt, then let me consider the case 2. Now what is case 2? Case 2 is 21. Right? We have seen a key which is there in the nodes. So let us see a case which is not there in the node, which is not there in the node, right? So when the node is found, we are making key found is equal to -1. So that is to be kept in mind. Otherwise, when we are actually in the global area, this key found is initialized to 0, is always initialized to 0. So if key found remains to be 0, it means what? And key found remains 0 means what? Node not present is the answer given by Aman Singh Jolly. Value not found. Not value. We are always searching for key. Yeah, Rohan, key not found. So Gautam, let's. I think what you meant to say is the key itself, but while typing, I think you have said value. But value is the value corresponding to that key. So we are always, search is always done using the key, not using the value. Reason being, keys are unique. Values may or may not be unique, right? So if you want to search, you have to always search through the key, right? Okay, now let's see the case 2 where k is 21 and as you are seeing 21 is not found. 21 is not found. So let's go. So when we call this function with k value as 21, flag set to 0, temp1 is over here. Temp1 is over here, right? Now, because temp1 is not equal to null, we are going to enter the while condition. We are going to enter the while condition. So 21 equal to 10, false. So it's not going to enter the first if condition. Now it enters the second if condition. What is the second if condition? 21 greater than 10. Answer is true. So it's going to display and increment the flag by 1. So temp1 of key is 10 and flag 1 has got incremented from this 0 to this 1 after the end of the second if condition. So this is the state. Flag 1 is 1. You are not going to go to the else block, but you are going to come in the temp1 is equal to temp1 of next, right? So you are going to go to 20, right? When you are going to go to 20, it is not equal to null, true. 21 equal to 20, false. So if condition is not meeting, 21 is greater than 20, true, right? 21 is greater than 20, which is over here, true. So you are going to enter display, flag value will become incremented to 2, right? Now the temp1 is equal to temp1 of next. Temp1 is equal to temp1 of next. So temp1 has come here. Temp1 has come here. So what is the value of k? 21 equal to 22, false. 21 greater than or equal to 22, again false. So it's going to go to the else block. It's going to go to the else block, print and return. It's not coming over here, it just print and return. So when it returns, the flag value is 2. When it returns, the flag value is 2. Temp1 is standing over here. Temp1 is standing over here. The flag value is 2. The flag value is 2 and your key found continues to remain 0. Continues to remain 0. Any questions regarding the case 2? Students, any questions regarding to case 2? What is the need of in K? Yeah. If you do not put this if you do not put this, right? Last time, uh, this is the case, k greater than this, right? If we do not put this, it will not go to the else block. That's the reason why we have put it as greater than or equal to. It has to go to the next iteration. If flag value is 0, then the first flag will be 0, right? Yes. First flag, no, you mean to say you are talking about this flag? Bhavana, are you talking about this flag? See, Bhavana, it is like this. Let me run it again. The value is k is 21. In the case 2, 21. Here it is 0, true. While condition true. This is false. This is true. That is 21 is greater than 10, true. Here it's going to become flag equal to flag plus plus. That flag plus plus I am reflecting here. There it is going to become 1. Bhavana. Are you okay with this, Bhavana? Should I repeat again? Initially the value sent is k. K value is 21. Flag is 0. Yes, we are incrementing after. Yeah, we are incrementing. So this state which we are seeing is after the printing job is done. So at the time of printing it will be 0. At the time of printing it will be 0, but after printing it will become 1. And there is a reason to increment it by 1. When you see the next code, that is inserting a node, that is the time it's going to be of help. Therefore, I have incremented it by 1. Yeah, Bhavana, Prabhanjan, Raghavendra, yes. Uh, See, Kiran Reddy, when k becomes 1, for example, in the first case, first the k was 22, 22 greater than or equal to temp 1, true. That is 22 is greater than 10, true. It has come again, 22 greater than 10, true. It has come again. Now k equal to how much? 22. 22 equal to 22. So I am returning it over here. There is no confusion. It is not allowed to come in the second if condition. Firstly, if is not a loop, if is a control structure. Okay. Raghavendra. Sir, are we printing key and flag in else part? Instead, we could print key not found. Yeah, we can also do that. Once you are coming to the else part, as suggested by Raghavendra, I can write a comment, key not found, and present node key we can display. Yes, we can do that. Key not found, we can add that comment and go out. Yeah. So case 1, case 2, clear? Or is there anything to be clarified? No issues. Raghavendra, what is your that init case, your query regarding the init function. Are you ready with the query? Acha, it was Rohan, is it, sir? The other day I was talking about pre-increment. Yeah. So just a minute. Yeah, Rohan, I'm seeing that level plus plus that will be in the express node. Ah, we are not incremented it, Rohan, over here. If you see the statement number 67, statement number 67, uh, sir, here it is fine, but in the slide, acha, okay, in the slide you are saying, okay, fine, let me check. Maybe there I might have done. Yeah, you are right. So level over here, I should make the correction. As it is in the code, I should make it level plus 1 and semicolon. Yeah. Is it now matching with the code? At statement number 67, statement number express first is equal to express first of level equal to level plus 1. Yeah. And thank you, Rohan. We have done that correction in the slide also. Yeah. Anything? Same question. Okay, Raghvendra, you had the same question. Okay, fine. So, should I proceed further? Now, something which is more little complicated, I won't say difficult. I'll try to make it as simple as possible with the explanation and the animation. And I'm hopeful that you will understand. I'm hopeful that you will understand. Now, I have named this function as insert between. I have named this function as insert between for the simple reason that whenever you are creating a linked list, there are two ways now. You add the node at the beginning, the new node which is getting added, it is added at the beginning or it is added at the end, and then you call for the sort function and sort it. That is one way of doing it. But a better way of doing it is at the time of insertion itself, if it is inserted at an appropriate location in the increment order of the key, in the increasing order of the key, then there is no need of once again calling the sort function. So with that idea, at the time of insertion itself, I am inserting it at the right position. Therefore, I have named it as insert between. Therefore, I have named it as insert between. Now, students, I hope the search program, all of you have typed it in your this thing, editor, Dev C++ editor. Okay, so please start typing it. Please start typing it. This insert between also. Please start typing in the insert between also. Now the first variable, that is a local variable, char yn, the character variable, yes, no. I'll come to that in a little while, maybe in the next or next to next slide. So there is a meaning for that. Then int ij, there are some for loops. So that for loops, I have initialized I. I don't think I'm using j, but just I have declared it in case it is required. I don't think I'm using it. Then we are asking the user enter the key to be inserted, right? Then we are creating a temporary we are taking a temporary point variable, not temporary variable. We are creating an isolated pointer. We are creating an isolated block and storing the base address of that isolated block in that curve, right? That is what is this. To this, we are initializing the key with whatever key the user is going to give, right? Now the problem is two. There are two things. One, the key may be existing, right? And as per the dictionary, yes, Jai Shankar, anything? Jai Shankar, anything? Okay. Now, suppose, for example, the key 20 is there, right? And the user asks to enter insert key 20. That's one possibility. Key 21 is not there and the user asks to enter the key 21, right? Can we enter key 20 again? Can we enter key 20 again? No. Why? Sanjana, why no? Key must be unique. Absolutely right, Sanjana. Yes. Rohan also is saying key are unique. Rishita is also saying key are unique. No duplicate keys. Very good. Very good. Nikhil, I am so happy with what you have written. We can replace the value. Right. Nikhil Reddy, I am very happy that you have said this. A key cannot be duplicate, means I can't have a linked list which has the key 10, 20, 20, 22, 22, 23, 27, 30, 30. No, this is a wrong way, right? So what Nikhil is probably trying to suggest, that probably at the present, at the key 20, the value is 2222 say, right? The user wants to change this value to 202020 say. The user is not interested in having a duplicate key which he cannot have only. Your logic should be such that the keys are unique. So even if somebody wants to intentionally give a duplicate key, you can only ask him, do you want to change the value? I can't change the key. I can't change the key. I can't have a duplicate key, or no two keys can have the same data. I can only do one thing, that the present value connected with 20, which is a 2222, I can modify it to 202020, right? So that is, are you trying to suggest that, Nikhil? Yes. So good. I'm happy that somebody is thinking about that. But rest, Rohan, Rishita, Sanjana, and Durga Prakash, and others, you have guessed it. Yash, you are absolutely right. Because the very basic thing, the main topic of Unit 2, there are two topics. One is hash table and dictionary. These are the two main topics in Unit 2. So we are dealing with the first topic, that is dictionary, and the dictionary says the key have to be unique, right? Corresponding to every unique key there is a value, right? But we cannot say we are talking in terms of lakhs of records. So it is quite possible that the user by mistake gives the key which unfortunately happens to be duplicate. So you have to give him an option that friend, key already exists. Do you mean to say that you want to change the value? That option should be made available, right? So now when you go and search, that's the reason why you have to search cutoff key. Where will you go? Just now I have explained you this search. Just now I have explained you this search. So that node has to be searched. Yes. So I'm calling that function and passing this cutoff key. I'm passing this cutoff key, right? Now, let's take the, let me first take the case 1. Let me take the case 1. What is the case 1? The case 1 is the user has passed 22. The user has passed 22. What is the 22? 22 key is already existing, and assume that corresponding to this 22, there is the value is 2222. Of course it accepts. Search function accepts no k. Jai Shankar. Search function is accepting the parameter k. Isn't it, Jai Shankar? Jai Shankar? Cutoff key is nothing but integer value, no? Okay. Right. Not an issue. Right. So let me say the case 1. What was the case 1? The case 1 was the user had passed k as 22. Right? The user has passed k as 22. When user had passed k as 22, the status of what? The flag was 2. Are you with me, guys? The status when k was 22, the flag was 2. Key found, we have made it as -1. Temp of key was at 22, and temp1 of value is 2222, which I am reflecting here also. Students, just now when I was discussing about the case 1, k is equal to 22. This was the state. Yes. So out of that, I have a if condition in the, we are presently in insert between function. In the insert between function, there is a if condition where key found is equal to -1, right? So we are going to come in this particular block, and before that, key found is equal to 0. So we are not going to enter here. We are going to come here, and in this, since the value of k is 22, this is the state. So at the entry, we are going to print temp1 of key, which happens to be 22, and temp1 of value, which happens to be 222, right? Now, because the key is found, and as suggested by Nikhil, I'm prompting the user, do you want to update the value, right? Do you want to update the value, right? I said flush because you are going to take a character. So it is better to flush the buffer. So flush the std in, and in this yn, the user may say yes or user may say no. There is a small y and capital Y. Suppose the cap lock is on and he has pressed capital Y. So we are catering for the user has entered small y or capital Y. Means what? The user is wanting to modify the current value with some new value. User wants to modify the current value with new value. Right? So if the user say yes, then we enter over here, prompt the user what? Enter the new value. Enter the new value. Where is the temp1 standing? As you are seeing it over here, temp1 of key is 22. So temp1 is standing right over here, and we are taking from the user some value, and that we are entering at temp1 of value. So the user, assume that, has said y, and the value which the user has given, assume that it is 202020. Value the user has given is say 202020. So this particular value is now going to get modified to 202020. Right? Then we are coming out of the if condition and resetting the found is equal to 0. So that next time the insert between function is called, we have reset the key found as 0. Is this case 1 clear? If the user enters the key which is already existing in the node, the only option left is that we cannot have a duplicate key. The only option left is that give an option to the user that when the key is already existing, if you want to make a change in the value, I can change the value. However, I cannot have a duplicate key. I cannot insert a duplicate key. Yes. We aren't initializing key font. Yes, we are initializing. At the beginning in the global area itself, I've initialized that font is equal to 0. Because you are going to search, and from the insert between function, you are going to search function. Search function had made it -1. Therefore, after using that -1 over here and coming in this if condition and modifying the value of the key, modifying the value at that particular key, I am resetting that key found is equal to 0. Go on side. At the beginning of the code itself, in the all the global variables, the value of key found was initialized to 0. Here at line number 6, go on side ready, flag and key found equal to 0. Right. So this is my case 1. Now let's see case 2. That is, what is the case 2? The case 2 is that we want to insert 21 between 20 and 22. We want to insert 21 between 21 and 22. Right? So the case 2, the user has sent 21. Right? When the user has sent 21, the flag value came to 2, and the key found is 0. I hope there is no issue regarding this, students. Last time when we went into the search function, we gave the same value 21. When we gave the value as 21, when it came out of the else block, or through the else block, when it came out of the search function, the flag was set to 2. The flag was set to 2. Are you okay with this? Or should I go back to the search function and bring you from there? Be frank. Be frank. Because the concentration level has to be absolutely high. So be absolutely frank. Are you okay with flag value as 2? Anybody has doubt? When the key was 21, the flag value has stopped at 2. Okay, as the chat window is silent still for my sake, yeah, when the K value was 21, when you came out of the flag, when you came out of this else block, because 21 is not found, the flag value has come to 2, right? Okay, so the flag value is 2, key found is equal to 0. Key found is equal to 0. As Bhuvan Sai Reddy was asking, when did we initialize that key found is equal to 0? At the statement number 6, we had already initialized it to 0. So key found continues to be 0 and flag value has got incremented to 2. Then we have printed and create node. Why are we creating a node? Because that 21 key is not found. If 21 key is not found, that node has to be inserted here. That node has to be inserted here. Yes, if that node has to be inserted here, I need to call the create node function. What is this create node function? We are cur is equal to this. We are prompting the user. We are prompting the user, asking him to give the value of the key. Give the value of the key. Then scanf cur of key. Enter the value. The user is going to enter the value, and cur of next is equal to null. So an isolated node like this is going to get created. Students, are you with me? When this function happens, the cur creates a memory block with three elements. Key we are initializing to 21. Value we are initializing to some -1111, and the next we are initializing to null because we are going to create just a temporary node in the heap area. It is not yet connected. It is not yet taken the correct position, right? Okay, so temp1 is equal to first. Assume that this is your first. Assume that this is your first. So temp1 is equal to first, right? Temp1 is equal to first. So this temp1 and first both are at this base address with this as 10 and this as -1111. The key can repeat. The key can be the values can repeat, but the keys can never repeat. Okay. So here also we have -1111. Here the user again wants to give -1111. No issues. The values can duplicate or values can come second time or third time or a number of times, but the keys cannot be repeated. Right. So the present state is that temp1 is here. And what is the temp1 of next? Temp1 of next we have this 20. Right? Temp1 of next we have this 20. So therefore in the diagram I have put the temp1 here. Temp1 is at the first. So at the present temp1 and first both are pointing over here. Right? and temp1 of next, that is temp1 of next is pointing to the base address of this, which has the key 20 and some value 2222. Now this I value initialized to 1. What the flag value? Flag value is 2, right? So first time it takes an entry into the for loop. First time it will take an entry in the for loop, right? Temp1 is equal to temp1 of next. So temp1 is going to jump from here to here. Temp1, which is standing here, is going to come here. Yes. So temp1 has come here, right? Now again we go to the top of the for loop. I has incremented to 2, 2 less than 2, because flag value is 2, false, right? So I'm going to come out of the for loop. I'm going to come out of the for loop. What is temp2? Temp2 is equal to another temporary pointer. So that temporary pointer, I'm storing temp1 of next. Any student can tell me what is going to get stored in temp2? Base address of which node? Very good. Sanjana, Rohan, Raghavendra, Bhavana. Very good. So temp2 is going to, yes, yes, Atal, fine. So you are Gautam, yes. Lakshmi, Aishwarya, fine, very good. So this temp2 is going to store the base address of this. Why are we doing that? Because we are planning to insert the key here. Insert the key here. When this cur is going to get inserted here, this null has to get replaced with this base address. Therefore, I am storing in temp2 temp1 of next. Right? Temp1 is over here. Temp1 of next I am storing in temp2. Come to the next statement. Temp1 of next is equal to cur. Why? Presently, temp1 is pointing to 22, but we should now change it to 21. Inserting after temp1. Very good. At this stage. So, to insert 21. Yes, Bhavana. Right? So, temp1 of next is equal to cur. So, earlier it was pointing over here. Now, we are making it to point to that isolated node. Now we'll make it to a point at the isolated node. Now one more step. Now this is null. This is null. So this null has to point over here. Therefore 20, 21 and 22. So we are not only inserting, we are also sorting and inserting it. Right? So let's go to the next step. Cur of next. What is cur of next? Presently it is null. That null has to be replaced with this base address. Where is this base address? We have stored that in temp2. We have stored that is temp2. Therefore, we point it here. We replace that null with the base address of that. And then we call the display function. And in the display function, we display the result. Clear, students? Case 2. Is the case 2 clear or any doubts? So we have to see both the cases. We have to see the case wherein the key is there. If the key is already there, we are not having two nodes with the same key. We are avoiding that. So we are giving a chance to the user to replace the existing value with some modified value. If the key does not exist, we are not only inserting it, we are inserting it in a sorted place at an appropriated ascending order sorted place. Now, coming back to, I'm forgetting his name, I think it is Raghavendra or Nikhil, I don't know, who said, sir, such operation should always happen through express node, right? We are exactly doing that Who was that? I'm forgetting. I'm sorry if I mixed up your names. I think it was Nikhil. Yeah, yeah, Nikhil. So Nikhil and Rohan, both of you. Nikhil, Rohan is saying Nikhil. So Nikhil, actually in the job of searching, we are always coming through the express node. We are always coming through the express node. So, but I have to explain you. I have to explain you this code also, because this code is going to be utilized somewhere else. This code is going to be utilized somewhere else. Therefore, I explained that. But your point is absolutely valid, and that is the way it is. The whole idea of skip list is to reduce the search time. And for reducing the search time, we have inserted a level called as express level. It could be 1, 2, n, right? And then if we go and start searching in the nodes, then what is the point? But my point again, Nikhil, is that if the node is not there in the express node, we have to come down to the normal lane, and in the normal lane you have to go stepwise to search for the and look for that particular key, right? So there this code is going to come very, very handy, right? So Shankar sir, I'll ask him to take over. He is going to explain you the query, yesterday's the last class quiz, and conduct today's quiz. Yes, somebody had something to ask. I missed the name. Students, I see only few names. So can you once show full code insert between? Insert between is starting from here. This is the second part. And this is the third part. Or should I show it to you in the dev C++? Because in one screen you can see here you are seeing in bits and pieces. Okay, just a minute, Bhavana. Yeah. Is this better, Bhavana? Okay. Shankar, are you ready? Yeah, Shankar. I should come on, stop the sharing. Okay. Okay, I'm stopping. Yeah. Students, please wait. Shankar sir is first explaining. Compressor.
Yeah, good afternoon, everyone. Yeah, good afternoon, everyone. Can you able to listen my voice? Just now I shared one screen, right? Last time meant before that last class we conducted quiz, right? So most of the students have done very well. I saw on the skip list. And today also I want to give a small quiz which kind of covers all the topics. Whatever the previous quiz are given, that I contain all the 2-3 questions I given about the most important questions I chosen, and I kept all the quizzes in today's quiz. Also, I gave a one program. It's an application of linked list. So, my voice is slow. See, everyone getting like this one? I kept my volume also high. Everything is high. Right now, now? So, Craig, now it's clear? Yeah, thank you, Suprit. Uh, the last list everyone is done because given the 10 questions, everyone is know that the skip list is a given. I just given the definition of the definition part as a taken as a 10 to 5 MCQs. Before that one going to skip list, I want to give that a definition skip list, which all covers all that whatever given. I will give one definition. It covers all that quiz questions. Okay, in a quiz, in a skip list, it is a probabilistic data structure which is going to search, or if you want to insert an element, take walk and walk login, and it's the best fastest searching, and it is going to uh, advantage, or it is applicable, or it can be used on advantages in a balanced binary search tree. Okay, you know what is balanced search tree. During the coming class, you're going to learn what is search tree, and the node will be there, left node, right node. If I give 10, the left node should be less than the 10, right node should be more than 10. So it has to be balanced. So it's an application for a skip list. So then in the coming classes, you're going to learn what is the binary search tree and the balanced binary search tree also. So first question, I just have to going to walk through it. Or given the what is the skip list? So option B is showing here. So what is the skip list? It allows a fastest search within an order sequence, because the skip list, whatever the values we are inserting, it is an ordered one, not in a zigzag way. So we should not ascending any. We are not giving values in a we call jumbling words, right? It's an ascending, or it is called ordered sequence. So option B, right? The skip list similar to which other data structure? Just now given that it is application for a balanced binary tree. Option B. The node in a skip list may have many forward references. So we know that one we will give some points, entry points, right? Suppose 10, if I insert 10, 15, 10, 12, 13, 14, 15, like that, 10 to some 50 values in sequence values. We will give a level 1, level 2. Level 1 is a 10. The level 1 will maintain 10, next 15, like that one, right? Like that one, what is an forward references which is determined is a probabilistic problem is starting, right? This is an option there. In the next, given the truths and false, uh, first one, what is the statement? What about the statement? Given the two statements about skip list, giving element, finding the closest elements to given value, it's sorted in the walk login. Just on the definition, and given the walk login of insertion and the walk login for searching also. Same thing you can see here, the point one, point two, finding the number of elements in a set whose value falls on a range in walk login. So it's not valid. It's not valid, right? Because we're not going to set a value which is going in range in the fall of walk login. It is sorted in the closest element in a walk login. So which one is a true? First one is a true. So that's one option A is true. And the second one, we'll go next one. Next question. How to maintain a multi-level skip list property when insertion and deletion are done? How to maintain? We will know, we'll keep a multi-level skip list, right? Multi-level, like in a level 1, level 2, right? It's called multi-level. What is the meaning of definition of multi-level? In each and entry point we give some I just want to draw a small picture. We will give some this is 1, 2, 3, 4, 5, right? Here we will maintain, right? One element set we will maintain for this one, right? This is level. Afterwards, if you want to maintain one more level like this, one more level, I want to combine also. This is levels. So how can you done all these things? It is designed, stored. All these are stored of a link in the place of element, right? So index we will call index, right? As whatever the roommates are stored, everything. So what is an index skip list? It is stored width of the link in the place of element, right? It's storing the width of the link in place of element. Given this is an two-level skip list. So the picture one also given the twist. How it will be there? Given as 10, then afterwards 15, some 10 to level 12, 13, 14 will be there. From 15, 16, 17, 18, 19, 20 numbers like that one. It's already sorted one. like that on 20 to 22 up to 5, 25, so and so and so on up to 30, 30, 35, 35, and so on 40, right? So if I want to search an element of 38, how to search an element? So 20 to 25 already we maintaining some level 1, right? Then 30, 35 will be there, one more. So how will search in 30 to 35, or we'll go for 40 and we'll search backtrack? No, right? We will search the number which one is greater, 38 first compared to 35. Yes. Then 30 to 30, 35 will compare with 38. 38 is greater. Then we'll compare with the 40. So we'll skip here and we will search linear 35, 36, 37, 38 like that. So how can we going to travel? 20, 30, 20 to 30, 35, then 35 we are going to search at 38 element. So option A is the correct one. Right guys? So just I given a basic quiz of what are the stars told in the class. I given a small case in this one. So it's a completely definition. It is one definition. It covers 4 to 5 questions in this quiz. Okay. And today also I want to go on want to activate one program for you. Before that one, I want to explain what is the program I given today. Right? Yeah, you want to create a one today. There's a program number 3. You want to create a one student data linked list. You have to create a one student linked list, right? Your student data list. So normal, what we will do? Normal, we will create a one node. In that we will enter some value on pointing to and one more value, right? Here we will have some address, right? Some address of this one previous next one. So here what you are doing, instead of inserting the values, you are going to insert a roll number in a one node. This is a one node number 1. So 1000 is a node 1. In the node 1, for 1000 node 1, you have to insert the value of the roll number 10. Name of the student is Ram, and one more what is the branch belongs to branch CSC. And this address is 1000. I'm assuming that it's 1000. And next, when I'm going to create one more link, in the link, you have to insert one roll number is 20, his name is Arun, and his department is IT, and make this an address of the next one, and create a three link here, 3 nodes. The third node 7 is a roll number, which is that name, and it belongs to EI department. So 1000 is holding this node, first node, 1001 is holding second node, and 1002 is holding the value of this one. So 1000 as referring to next pointer, address is 1001. This node again pointing to 1002, and the next one is not inserted because that address is not. So we have only created 3 1. You have to create this one as a linked list, and you have to print in an or I can call in alphabetical order. I can call as an ascending order. It's called sequence order also. So first what is an alphabetical A will come, or we can call dictionary order also. So first it has to print this node. Node 2 has to print first. Node 2 has to print. Then afterwards, next which value will be the next dictionary order is B. Next it has to print node 3. This it has to print node 3. Then you have to print node 1. Like that one you have to display. First insert that elements like this one. Given only one test cases, you have to execute this one test cases. You have to insert node 1 of this person, node 2 this person, and node 3 this person. But you have to display how you are going to display with the help of an alphabetical order, or we can call as an ascending order, or we can call as a dictionary order, whatever terminology. So first A will come, right? Arun. If I talk a dictionary order, A will come, right? It has to print Arun. Then next order is B, bridges. So next node 3 has to print the value, and node 1 has to print. Like that I given the time. So this will be opened till I can call as a Monday. I will not stop this one. So today or tomorrow, today is a Friday, Saturday, Sunday also give you 2 days of time. You have to do this one. So the problem I given, write a C program to create a linked list of inserting a student details, right? Student details, and it has to display student details in ascending order. Every node containing student roll number, name, and code. So it has to print like that. In the input, you have to take enter the student one details. You have to 10 is a roll number, and RAM is a student name, and CS is a course name. It's the first node. And second node, it has to ask that one from input, enter the student two details. That time you have to enter 20 and Arun ID. And the third one also, the second node is created. The third node, again, it has to enter the student three details, 7, bridges, 8. Only for 3, right? Then afterwards, you have to go into print in an what is called ascending order. So A will come first. So 20 RN and IT is department. Next one is an called bridges. So bridges 7 is roll number, bridges and EI. And the next is RAM 10 transmission. This program you have to go to execute. And I'm giving the 2 days of time. It's an assignment for everyone. Okay. Guys, do you have any doubts? Please raise me. If you have any doubts in the program, please ask me the questions. I will clear you. And the quiz, the script quiz is a basic questions or definition. For the definition, I given the 4 to 5 MCQs are developed. And today also one more quiz is there. I'm going to activating that today. And this is hardly of 10 minutes or 15 questions, which covers all your topics. It's a queues, stacks, linked list, implicit notations. Even if I did not get the script list, you complete a unit 1.